And this slide here, if you go to the FutureGrid webpage, you can get a rather good description of feeling for what's going on from the various short descriptions. Here we have Peter Dinder from Northwestern looking at new virtual machine technology. We have experiments on using GPUs, workflows, improving the core technology Nimbus. We have a couple of classes, one in Croatia and one in Puerto Rico. These are recent projects. The Ocean Observatory Initiative is a big NSF project to support ocean science, and we have a security project. So, and here's yet more projects. So you can browse those at your leisure. Here's some examples in education and training. Jerome Mitchell, who is around, and he will be giving a talk tomorrow. He's had a cloud workshop at Elizabeth City State, and we have this summer school, and we are also trying to build some tutorial material hosted by FutureGrid and based on a book I wrote. As a sort of example again of usage, we surveyed some of the interesting uses recently, and we had one project from Portugal was looking at fundamental computer science, so-called concurrency control or transactional memory. So that was one project. We also had important work from Rutgers, which is one of our sites, from the Saga project, and from USC, which is looking at Pegasus. We'll hear about that work on Thursday. As an example of another type of application, we had work on supply chain network simulation done from a student at Arkansas. So it's a pretty rich set of applications. We have a whole bunch of tutorials which you can access. I won't go through those. This lists the types of services which we have. We have HPC services, MPI, OpenMP, CUDA, grid services, Genesis, Unicore, Saga, Globus. The infrastructure I mentioned, we focus on Nimbus, Eucalyptus, OpenStack. Vine is the virtual networking technology from Florida, which will be discussed on Friday. And then we have platform as a service, which will be discussed mainly tomorrow in Judy Chu's session. And this particular one shows that at least although we can do dynamic re-provisioning just to keep life easier, we do tend to provision things statically, and this shows you which resource is typically available on which machine. So you can look at my PowerPoint to go through that in detail. This shows you the growth of FutureGrid use in time. It shows the actual usage is pretty constant. If you look at which technologies are in access most, you'll find they don't change very much with time. The leading requested technologies are HPC, that's MPI, Eucalyptus, Nimbus, and Hadoop. So Hadoop being what which Michael just described. So those are the largest categories, and then we have a lot of other categories, including Twister, which is iterative MapReduce, Genesis, grid software, MXC software stack, and those are roughly increased linearly with time. The only one that's non-linear is OpenStack, because OpenStack didn't exist at the beginning of our project. If you look at what's needed to make FutureGrid work, it's a sort of standard stack. The one area which we'll describe on Wednesday, which is new, is RAIN, which is the software that does the dynamic provisioning. We build on, of course, these other things like virtual cluster and virtual networking, which come from the cloud community. So that's built into things we use. So this tries to capture what FutureGrid does. I've already had you this, in my first talk I had infrastructure as a service, platform as a service, and software as a service. FutureGrid offers what I call testbed as a service. It allows you to use all those different usage modes, software, platform, and infrastructure, and it provides the software that enables one to instantiate each of those types of usage modes. I added here this concept I introduced called research computing as a service, which sort of tries to capture the idea that we have these three major categories, and yet we also need to offer them as a service to real users. FutureGrid is offering you the ability of testing, but then almost every computer center or computer organization in the world wants to be able to actually use these capabilities, and that's what I call research computing as a service. And I see that this area, although it's reasonably traditional in terms of concept, in terms of implementation, is going to require significant changes, because we're going to see a growing use of, in fact, cloud computing, the existence of platforms like Amazon and Azure, where the computer center may not have the hardware actually on site, rather it's going to be supporting users from, say, their university, which are actually going to be using commercial vendors. So I think this is going to be an area of great change, which deserves some study and thought as to how we do research computing and how we support it, so this impacts the users and the people supporting users, how we do that in this world where clouds are getting more important. And so this slide here describes some of the things that are involved in research computing as a service, and describe maybe things that the user will be doing, and the people who are supporting users. The first item here is one of the things you'll be learning about in this class a lot, which is actually building the images. I pointed out that this concept that we had specialized images, you see Michael would have a specialized image built around it with software like Bowtie built in. We are going to be building images to support different applications, and each application or each application class might have different images of what Azure calls roles. So I think that's going to be a pretty interesting area, deciding what those look like. Michael also mentioned the critical data transfer problem. We're clearly going to have the expertise in how to get the data from where it is to where it's meant to be, but also, so we need that expertise, and also we need to persuade Internet 2, who's actually hosting this video conferencing, to be able to help us do that transfer. Michael really nicely emphasized the critical need to have the data somewhere and bring the computing to the data. The key problem is this data, how do we get the data to where it ought to be, which, as he said, is likely to be on a cluster with quite a lot of disk per node. And how that actually happens is not so trivial, and a lot of work is needed.